Right, friends. So we have already discussed how executor service really works. So this is the part of your core Java, and what happens is that when you use streams, when you use streams, we have already seen streams in action. You can very well get the elements processed. The stream is actually a wrapper over some of the other data source. It's an iterator over some of the other data source, and then it helps you with some higher order functions in order to do map. You can do filter, you can do flat map, loads of things. But if at all you wanted to process the elements in parallel in stream, then in that case what you can do is that you can just simply say dot parallel out here. Okay, and I'm going to revisit this for sure. I'm going to come back over here and I will explain to you how parallelism works over here and which kind of thread pool is used. Threads are picked up from which thread pool, and the elements are picked up in those threads, and they are processed. So I'm going to revisit and I'm going to come back to this for sure. But before that, you know we've got, I mean, executive services already discussed here. But then if you've got to work as far as flux is concerned, and if you want to process the elements that are there that are there that are published by flux, if you want to process those elements in parallel, if you want to subscribe for the elements on a parallel pool, on a threads coming from a thread pool, maybe parallel or elastic, there are various different thread pools available. If you want to do that, then how do you do it? That's what we will be discussing. But then before that, understand there is something called, so I will now this time take up a different package altogether. I'm going to go back to my reactor package, you remember, and we do have pom.xml file out here. You can see this here. In this pom.xml file, we do have in a reactor core already set as the maven dependency. So I do have in this plain Java project, it's not a Spring Boot project yet, but in this plain Java project I do have reactor libraries. You can see this maven dependencies, and here we do have reactive libraries here as a result of that, including this dependency project reactor. Okay, now coming back. So there is a component, I'll say class. So I'm going to come to I will revisit streams, and I'm going to go ahead with ParallelFlux as well. But before that, understand that there is something called schedulers demo, and there is something called a scheduler service. Now what does that mean? Not actually a scheduler service, but then see this, you do have like the way we worked with executor service, and we said service, right? And we did say executors dot, and we said new cache thread pool, or maybe new fixed thread pool, and then we said 5 or whatever number of threads that we want in the thread pool. We have already seen this in action, right? Similarly, project reactor provides you with yet another thing called scheduler. You can see this scheduler, reactor.core.scheduler. Please see, reactor.core.scheduler is what it provides. And I'll say I'm going to, like you can see, executor service here, I've got a scheduler, and then I say scheduler, okay, is equal to how do you create a scheduler? Like in this case, you create a thread pool with the help of executors dot new fixed thread pool. Here you do it with the help of schedulers dot. For example, there is one of the factory methods provided called parallel, which gives you the complete scheduler object, which gives you the scheduler object. You got that? So I've got scheduler is equal to schedulers.parallel. This gives me a scheduler using which I will be able to schedule tasks to execute. I repeat, I will be able to schedule tasks to execute. Now this will give me exactly the same behavior that I had from my executor service. So I'm going to comment this because this is not what we are going to use here. We have already used some executor service, and we have already seen that in action. I'm going to pick up exactly the same piece of code, and I'm going to come here and copy paste it. It is just that instead of using the service here, you can see this, instead of using the executor service here, I will be using what? I will be using the scheduler. You can see this, scheduler dot, and instead of execute, it will be schedule. Same thing, everything else remains exactly the same. right? And I'm going to put the number of tasks over here would be 16. I'll tell you why exactly I'm giving the number of tasks as 16. I'll come to it in a moment. But then I'm saying the number of tasks is 16, and I'm creating a countdown latch for 16, with the number 16, and then I take a timestamp, and then I say scheduler.schedule, same, I'm passing runnable as a parameter here, and I say thread.sleep. I put this thread to sleep for 1 second. So each one of these tasks that are submitted using the schedule method of a scheduler, it's going to take 1 second to complete, right? And then I have a last data wait over here so that I can take a timestamp only and only when all of the tasks are completed, and I get to know how much time did all of these tasks take, how much time did all of these tasks take to complete, so I say n minus start, same stuff, but here I don't have to do a shutdown at all, because anyways the thread that I have, in this thread pool, the threads that I have in the thread pool is they are actually daemon threads, so I don't need to worry about closing them up, right? So far so good, everything is good. Now point here is that how much time will this take? In case of an executor service, we used to create a thread pool with a specific number of threads. You remember we did that, we did that loads of exercise, like, we created the number of threads were lesser and the tasks that we submitted were higher, and then we had equal number of threads equal to the total number of tasks that we are submitting. We have all done that, and we have seen that in action. At this point of time, I'm using not an executor service but schedulers, which comes from where? You can see the schedulers, it comes from where? It comes from reactor. Right? And you will soon realize why we are getting into the schedulers. Why are we trying to understand schedulers? It is imperative, friends, if you want to go ahead with parallel processing of the data that is published by Flux, then in that case you must understand schedulers, without which it's meaningless to go ahead with ParallelFlux. So please see this, right? So we've got Schedulers.parallel. Now what this does, this gives you a pool. I repeat, this gives you a pool of threads which is equal to the total number of threads, total number of cores on your machine. So if on my machine I've got 16 threads, 16 cores on my machine, the Schedulers.parallel will end up giving me 16 threads, right? 16 threads will be there in the pool that is managed by the scheduler. And you see this, since I am submitting all the 16 tasks, I have 16 tasks to submit, it will allocate each one of those threads from the thread pool to each one of these tasks. That means each and every task that I say schedule over here, like this runnable is one task, and then I'm in the loop and total number of tasks is 16, so it will keep on submitting. It will just submit how many tasks? 16 tasks. Each task is going to take 1 second. So definitely it's going to pick up, if one task is given to a thread, and if it is going to take 1 second, it's not going to wait. Of course, the other task is given to the other thread, and the third task is given to the third thread, and so on. All right, let me run this and show you the results. I'm going to get how much time. So if I say that Schedulers.parallel will give me a thread, a thread pool, that will be managed by the scheduler, and the thread pool will be having threads equal to the total number of cores on my machine. And you all know that the total number of cores on my machine is 16. So tell me, in the number of tasks here, if it is 16, how much time will this entire thing will take to complete? Come on, friends, tell me. I need an answer. I'm waiting for an answer. Tell me, how much time do you think it's going to take? How much time do you think it's going to take? 1 second? 16 seconds? Yeah, tell me. 1 second. Yes, Tejas, exactly, you're right. So it's going to take just 1 single second. Absolutely. Let me click right mouse button, run as same stuff, but the number of threads is, you see this, it's taken approximately 1 second. It's the same stuff here. See the name of the threads out here, friends. The name of the thread is parallel 1, 2, 3, 4, 10, 13. You can see this here, 6, 7. So all of these tasks are submitted in one of the threads from the thread pool, and this is how it is, and this is what the name of the threads are. By default, it's prefixed with parallel. There are 16 threads prefixed with parallel. You got that? So 1, 2, 3, 4, and then you've got 5, 6, 7. You've got 8, 9, and you've got 10, you've got 11, 12, 13, 14, 15, and here it is 16. You got that? 16 threads all in all, right? That's how it is, and that's how it works. Even if I increase my total number of tasks over here to 32, now how much time will it take? Now you see this, Schedulers.parallel as schedulers.parallel, it will always create threads equal to the total number of cores on your machine. And now tell me how much time will this take? I have just doubled the number of tasks, friends. Tell me, I'm waiting. Tell me how much time will this take? 2 seconds. Yes, exactly. It's going to take 2 seconds. I'll say run as Java application. Very correct, Tejas. It's going to take 2 seconds. And you see it has taken 2 seconds here. Correct. That's how it is. So the number of threads are not increasing. It's not increasing. It's not decreasing. I repeat, the number of threads will not increase, will not decrease. And this is again a kind of a singleton. It's actually a singleton. If you say schedulers.parallel 10 times in your same application, it's going to be the same pool. It's not going to drop and recreate the pool, drop and recreate the pool. Absolutely not. It's going to reuse the same thread pool n number of times. Whenever you say schedulers.parallel, it's going to use the same thread pool. You got that? That's exactly how it is. So schedulers.parallel gives you a scheduler with a thread pool which has got total number of threads equal to the total number of cores on your machine. But is that the case? That's exactly how it is supposed to be. Maybe in some cases you would need threads more than the total number of cores on your machine, or maybe lesser than the total number of cores on your machine. So if you wanted to customize the threads, the number of threads here, you can very well do that. So you see you've got a function here called new parallel. Can you see this? There are several overloaded functions here. When you say new parallel, and if I say the name is yaba daba do, okay, if that is the name that I give, this will be the prefix used in order to name your threads. So I click right mouse button, run as Java application, and you see this here, friends. The name of the threads is, right from Java 1 to Java 16, right? And it takes the same time, 2 seconds. Obviously everything else still remains the same. But now you see this here. I'm going to say, I've got new parallel. You see this new parallel here. It takes two things here. Okay, take this third overloaded function. It takes two things: the name also, whatever is your custom name of the thread. Now the Java will be prefixed with the name of the thread. So Java 1, Java 2, Java 3, and parallelism. If I say 32 out here, it will create 32 threads, right? Which will neither decrease in size nor will it increase in size. You will always have 32 threads created in the pool. Always it will be 32 till the time it's there in memory. It's going to be 32. It's not going to come down. The count is not going to come down. The count is not going to go up for this scheduler at least. And now it will take just 1 second to execute. Not that my cores on physical cores will increase by it will become 32. Impossible, of course. That's a no-brainer. Of course, the total number of cores on my machine remains 16, but still it is going to take 1 second. 32 threads, 32 tasks. It's going to take what? Still, it's going to take 1 second. Am I right? See, it's going to take. Why? We have already discussed this while discussing the executor service. Here, this thousands milliseconds of sleep does not require the computing power of your cores. It does not require the computing resource. It does not require to hold on to the core. It yields the core because thread.sleep is supposed to just simply sleep. It's supposed to be dormant. It does not really use your core for that 1 second. And these two lines of code are absolutely something which takes negligible amount of time on the core. So 32 threads now in the run queue. Each one of those threads gets very efficiently. The OS scheduler manages it. It gets each one of those threads get time slice such that all the threads get executed with this just petty code over here in 1 second itself. Right? Because if at all this was, suppose if this was compute intensive and not suppose sleep for 1000 milliseconds, and if was compute intensive, maybe it takes 500 milliseconds, maybe 1000 milliseconds, then in that case, of course, your 32 threads will not complete doing its job on the 16 core machine in once. All together itself. It may vary. It may be still lesser or it may be more. Okay, that's how it is. Anyways, my objective here was to explain that you can very well have different types of parallel threads here. Right, and you can increase parallelism by specifying how many threads you need in that particular pool. Okay, you do have other things over here. You say new parallel. You can say parallelism. Say, for example, if I say 32 again, and I can create my own threads. Instead of scheduler creating the threads and putting in the pool, you can customize the creation of the thread, and you can specify how the threads will be created. You can specify whether these threads will be daemon threads or non-daemon threads, and so on. All right, that's what you can very well do. Okay, I'm closing this. Why? Because the other threads that you created, with see this here, when you say parallel out here, you can see. Okay, I click right mouse button, run as Java application. Okay, it's going to take what, 2 seconds, study to task, and then it's out. It's out. Why? Because each and every thread here you see executed in parallel thread 4, 5, 6. Let me show that to you. Here these are all, I'll say thread dot current thread dot is daemon. They are all daemon threads, right friends? They are all daemon threads, right? Got that? I click right mouse button, once again run as Java application. You see this, they are all daemon threads. So all the threads that are in parallel pool, Schedulers.parallel gives you a pool. It gives you a scheduler which has got a thread pool, and the threads in that are daemon threads. But if suppose you create your own thread pool using new, kind of a custom thread, will say new parallel, okay, and then you say the name is, say, whatever, okay, anything. Now you see this when I say run as Java application, and you can see this time it's false. That means when you use new parallel, the threads that are created are not daemon threads, they are non-daemon threads, and hence my JVM is not out. Why? Because these many threads are non-daemon threads. Of course, if there is even a single non-daemon thread running in your JVM will not exit. You got that? I destroy this now, and then I go back to parallel again, and to show you that your JVM will exit. Why? Because all the threads that are there in this thread pool are what? They are all daemon threads, and you see the JVM exists after your program completes. Correct. Now see, I was talking about new parallel, and you see your thread factory. So I'll say maybe 16 again, and thread factory, I can very well say new thread factory out here, friends. You can see this here, right? New thread factory, take a look. This is an anonymous class extending from thread factory. Thread factory is an interface which just simply has got one function called new thread. So you've got to implement that new thread. Now you decide how you would want to create a thread. So I'll say thread, I'll say T is equal to new thread. I will have to pass that R as a parameter, the runnable that it passes as a parameter, and then when I say return T. But before returning, I can do loads of things. I can say set daemon to true or false. I can very well say set group. You can see the set priority. I can very well do. You can see that, right? Okay, well, you can get a thread group and stuff, and while creating the thread itself, you will have to, yes, while creating the thread itself, you can very well give the name of the, you can see this here, you can give the name of the thread object as well, and you can very well specify string name, runnable target here. Yes, correct. So all of these are the constructors that you can use in order to create a thread, right? So you can specify exactly the characteristics of the thread before it goes into the pool. That is the reason why they have given you an additional feature of having a thread factory, right? Or else you can also very well specify you say new parallel, you've got thread factory parallelism, okay, and then see there is yet another constructor wherein you say the name is whatever yabba do, and then you've got parallelism as, say, for example, whatever say 32, and if it's a false, it won't be a daemon thread. If it's a true, all the threads will still be a daemon thread. And you can see this, I click right mouse button, I say run as Java application. Since you have said that all the threads are supposed to be daemon threads, you see they were all daemon threads, and my JVM exists. It exits out. You can see that the JVM exists. So this is the power that you have in your hand. This is what a parallel schedulers.new_parallel or schedulers.parallel gives you. Correct? All the more over and above this, fantastic things. Please see here. You also have something called, I'll say schedulers dot, I have something called elastic. You can see this here, elastic. Okay, now what this elastic would do, now this elastic is deprecated in the latest version of your project reactor, which is 3.4.0, until the previous version 3.3.10, I believe, .1. Okay, and that version, elastic, till that version elastic was not deprecated, but now it is deprecated in favor of bounded elastic, or new bounded elastic. We will come to that in a moment. But what will elastic do? This will keep on creating the threads as needed. As you keep on submitting the task, it will keep on creating new threads, new threads, new threads. It will just simply keep on creating the threads. You got that? It will just keep on creating the threads. But if at all it sees that a particular thread is free for 60 seconds, idle for 60 seconds, it will just simply remove that thread from the pool. So that from 0 it will keep on. So it doesn't really start with 16 threads or 8 threads or whatever the total number of cores on your machine are. It will just simply create the thread as needed. So it starts with 0, it will keep on creating threads. Okay, as needed. As you keep on submitting the task, it will keep on creating the threads. Okay, of course, assuming that all the other threads that it has already created are busy. Of course, at any given point of time, if suppose there are 5 threads created in elastic pool, and if at all of them are free, or at least one of them is free, then in that case, when you submit a task, of course it's not going to create a new thread. It will reuse the thread that is absolutely free. But whatever the number of threads at a given point of time is in this elastic pool, if those number of threads are all busy, it will, and if you still submit the task, it will keep on creating threads if there is a need. If but a particular thread it sees is idle for more than 60 seconds, it's going to remove it from the pool. Okay, that's exactly how it works. But okay, so let me execute this. Now I'm going to get this executed in 1 second, because it's going to create 32 threads, right? Here you are, approximately 1 second. You see this elastic, and of course the threads there are daemon threads, and see this, the name of the thread is prefixed with elastic, so, and followed by whatever the number of threads are, elastic 1 2 3 4. This is how it works. And then over and above that, you have something all the more fantastic here, bounded elastic. Please see this. What will bounded elastic do? But what is how is elastic different from parallel? Is parallel elastic in nature? Will it keep on increasing and keep on decreasing? No, absolutely not. If you say parallel pool is of, say, even if you specify your own parallelism 32, it will create 32 threads, will never decrease the size of the pool, and will never increase beyond 32. But in case of bounded elastic, or in case of elastic, see the term elastic, elasticity, stretches and comes back, stretches and then comes back, right? It shrinks and stretches, shrinks and expands. Okay, I will say it shrinks and it expands, it shrinks and it expands. It expands the size of the pool as needed, but also shrinks. And by default, what is the time to live? What is that shrink? Shrink is going to happen based on what? If it is idle for 60 seconds, it's going to remove the thread from the pool. Any given thread, if it is idle for 60 seconds, it's going to remove it from the pool. So you see the size of the pool keeps on increasing, coming down, keeps on increasing, coming down, based on the traffic. Traffic is not the right term here. Based on the load that you give to that thread pool, based on the tasks that you submit to, the number of tasks that you submit to that thread pool. Correct? That's how it is. So now with bounded elastic, how is this different from elastic? Bounded elastic will create the total number of threads equal to the total number of cores on your machine multiplied by 10. Please see this. It very clearly tells you. See this in the documentation. Note that if a thread is blocking or blah 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 blah, no, this not. See this. The maximum number of created threads is bounded by, by default. You can see the CPU cores, available number of available CPU cores multiply by 10 times. You can see this 10 times the number of available CPU cores. So if my machine has got 16 cores, how many threads will be created? 160 will be created, right? And not beyond that. So what I'm going to do here is that I'm going to say 160 tasks to be executed, and I'm submitting 160 tasks. With bounded elastic, it's still going to take 1 second. Why? Because there are 160 threads here. You can see this is still approximately 1 second, and you can see here it has created those threads. You can see. Got this? Now what I'm going to do here is that, so it's going to create 160 threads, but not beyond that. That's bounded. In case of elastic, it was unbounded, but still elastic. But this is elastic in nature. Yes, of course, if at all any one of these 160 threads is idle for more than 60 seconds, it is going to bring it down. It's going to remove that particular thread from the pool. So the size of the thread pool keeps on shrinking, expanding, shrinking and expanding based on the total load that it has. Bounded elastic, 160 threads, which will create max, not beyond that. Let me make this 320 then in that case. Okay, let me click right mouse button here. Now 160 threads, but I have got how many tasks? 320. Needless to say, it's going to take 2 seconds. I hope you guys are all with me, friends. All with me? All right, see this 160 threads out here. Yeah, 160 threads, but then I have 320 tasks here. It takes 2 seconds, absolutely. Got that? Any doubts, any questions here, friends? Pretty simple stuff. Very simple. Now here also, you've got other functions as well. You've got a new bounded elastic, right? You can specify the thread cap. By default, the bounded elastic will give what? 100 and okay. On my machine 160, but the right statement is the total number of CPU cores, available CPU cores on your machine multiplied by 10. Correct. Here you have new bounded elastic. You can specify the thread cap. I say no, I want not 116, not 16 or whatever. I would say whatever is the total number of cores on my machine divided by or multiplied by 5 or multiplied by 2 or multiplied by just 3. You can specify. I can say 30 threads. I want 30 threads in the thread pool. That's it, no problem. Queued task cap. Now what is this? Whenever a task is submitted to a scheduler, whenever it is given to the scheduler to execute, it actually first queues it up. It will put it into the queue and then start taking the task from the queue and getting it executed on the with any one of those available threads. So suppose you have just 30 threads, but if suppose the tasks that you have submitted is suppose if I give 100 here, that means that the most 100 tasks can be queued, and if at all the 30 threads are busy and you have submitted 100 more tasks, those tasks will be queued, and now if you submit yet another task, it will throw a rejected execution exception. I repeat, it will throw a rejected execution exception. So this is how it is, and you can give a name. You will say, my elastic, something like that. Okay, right, my elastic or whatever. I can give any name that I want. Now this is how it will name the threads. I say run as Java application, just 30 threads. I've got 320 tasks to complete, you see, but then it's capped what at 30 threads. You can see this 30 it is executing, because the total number of available threads is just simply 30. You got that? It has taken 11 seconds to complete the whole thing. Needless to say, 30 and 320 approximately 10 times more the task as compared to the total number of threads that are there in the pool. You got this, friends? Yes, pretty simple stuff. And 100 tasks are queued up, but then there were threads which were picking up the task. But if suppose all the threads are busy, and if suppose you still submit many other tasks, then in that case, and if the queue is getting full, it will throw a rejected execution exception. And please see the name of the threads are also prefixed with my elastic. Right, beautiful stuff here, friends. Please see, I can very well say new bounded elastic, and you see again the same thread factory stuff and all, but you have make a note of this yet another thing. You can say thread cap, I say 30. Queued task cap, okay, at the most 100 tasks can be queued up. What is the name? Okay, name is say my elastic thread or E, suppose something like that. TTL seconds, I've been saying that always, if at all the thread is free for 60 seconds, then in that case, it will remove that thread from the pool. Here you can specify the time to live in number of seconds, in terms of seconds. If I say 3, now no 60 seconds, 3 seconds. If I say 30, now no 60 seconds, 30 seconds. If the thread is free and idle for 30 seconds, it's going to remove it from the pool. Simple. All right, you can increase it to 160 seconds or whatever time you want to give, till whatever time you would want the time you would want the thread to stay there before it is actually removed. Right, assuming of course it was idle till that time, then it will be removed. So see the power that you have got with schedulers. You've got schedulers.new-bounded elastic. You've got schedulers.parallel. You've got schedulers.bounded elastic, which will be bounded by a cap automatically based on the total number of cores on your machine multiplied by 10. So you have all of this power in your hand. Now, friends, see, this is the critical point that we are coming to. So you have understood this component schedulers, right? I assume, I believe, I'm hopeful that it's crystal clear to you. Since we have now, see, this is the reason why we discussed, we spend so much of time on executor service. Here, we did not really, we don't need to spend so much of time. We just need to understand the different thread pools that are available here and the behavior of these different schedulers, right? Which of course works with its own thread pool based on based on whatever you have specified here, based on how you have constructed the scheduler. Correct? Behavior is the same. I mean, it's all about multiple threads. It's all about executing things in parallel. We've already understood executor service, so it was cakewalk for us to understand schedulers as well. All right. Now, take a look at, what is the difference between, as far as parallelism of streams is concerned, and the parallelism of flux is concerned. See the difference here. Now this is $1 million, friends. Please don't miss this. I want 100% attention here, undivided attention, friends. Please see. I'm going to save this as it is. I'll just close that, and I will go back to streams demo, friends. Please see. I'm going to go back to streams demo. With this streams demo, what I'm going to do here is that, you see, I just mentioned this, I just did this. I did parallel. Okay, I'll do away with that parallel. I will do away with this filter also. I don't need a filter here. I have a point to prove here, so I'm going to just open and close this. I'll say return x.to uppercase. Pretty simple stuff. I'm using a map. I'm doing a transformation here. I'm transforming the given string into uppercase strings. That's what I'm doing. Just simple. I would like to print here in which particular thread this is getting processed. So I'll say x is getting processed in, okay, processed in, okay, I'll say plus thread dot current thread dot get name, right? That's what it is. Got this? Pretty simple. I am going to click right mouse button run on this, and you see this, it very clearly says that it's a main thread. Come on, friends, see this, it's a main thread, right? You got that? You got this, right? It's processing each one of those elements in the main thread. That's the thread in which I've written the code. So whichever thread here, it happens to be the main thread, right, in my public static void main. But otherwise, wherever I read, I write this code, wherever I have written this code, in whichever, wherever in my entire application, in whichever thread I have written this code, it is that same thread in which, so whichever thread is executing, it is the same thread in which this processing is going to happen. So if there are 1 million elements out here, it's going to take, whatever time it takes, but one single thread. And please see this, friend. I am also going to print, what I'm going to do here is that I'll say thread.sleep here. Okay, I'll say 1000 once again. Okay, so I'm putting the thread to sleep for 1 second. I'm putting the thread to sleep for 1 second. So I click right mouse button, run as Java application. Of course, it's going to process. It's going to take 1 second for Nomura, 1 second for Verizon, 1 second for IBM, 1 second for BNP Paribas, 1 second for Morgan Stanley, and then JP Morgan, and then I get the data. So that means it's going to take, what are the total number of elements here? 1, 2, 3, 4, 6 elements here. 1, 2, 3, 4, 5, 6. Yes, 6 elements. So it's going to take 6 seconds. You got that? Suppose I want best throughput. I want best throughput here while processing these elements, while converting them to uppercase. Okay, of course we are making up things here, and hence I am saying, thread.sleep. In real life, of course, converting to an uppercase does not take 1 second, but maybe you write some code over here which may be compute intensive, and it may take some milliseconds out here, right? So that's what I'm trying to make up here. So suppose it's 1 second, and then each one of those elements takes 1 second, but you do not want this. You want each one of those elements, in short, you want the streams to do the processing in parallel. I repeat, you want the streams to do the processing in parallel. Now what you do in such a case, I'll say parallel. You can see this. I just have to do this dot parallel. That's it. Now, you know what it's going to do? It's going to pick up the threads from a thread pool called fork join pool common pool. You remember some time back we did talk about fork join pool that I have used in one of my applications, and I did demonstrate that real life code to you. So when you have a fork join pool common pool, it's a singleton, it's one single common pool, and you have this you've got this this stream written, and I'm just saying dot parallel. It will use that fork join pool common pool. In other words, your stream will make use of the threads that are there in that fork join pool common pool. And how many threads are there in fork join pool common pool? The total number of cores on your machine minus 1. I repeat, the total number of cores on your machine minus 1. That's what would be the total number of cores in that fork join pool common pool. If you've got a quad core machine, you will see that the total number of threads in the fork join pool common pool is 3. If you've got an 8 core machine, it will be 7. If you've got a 16 core machine, it will be 15. In my case, of course, it's going to be 15. Take a look, system.out.println, and here I'll say runtime dot get runtime dot available processors, and just for the sake of skipping the rest of the things, I'll say if true, I'll say return. Of course you don't do this in your real life. I say run as Java application, and you can see this, it prints what? 16. This is the total number of cores on my machine. But see here, I'll say fork join pool dot common pool dot get parallelism, and see the total number of threads here. Now -1. So you see the 16, and here fork joint pool common pool has got 15 threads. Why? That's how that's what the that's how the stream processing happens. What it does is that I'm going to just put a I'll remove that, and now you see what it does is that it will pick up one of the elements, while iterating over the data source. It will pick up one of the elements, and it will make use of, okay, instead of saying one of the elements, it's going to pick up whatever element it picks up. It's going to execute it in one of the threads of the fork joint pool, and it will also include the thread in which you have written this code as a party in that parallelism. That means here in this case it's the main thread in which I've written this code, so one of the elements will be certainly processed in main as well. In other words, the main thread will also be a party here. So my one is that the containing thread, the main thread, or wherever you might have written the code, that thread plus 15 threads from the fork joint pool common pool on my machine. In any case, 16 threads would be executed. 16 elements will be executed exactly in one point of time. I repeat, 16 elements will execute exactly at the same point of time on 16 different cores, right? Okay, I think you have a question here. Let me check. So what I'm doing here is I am checking my messages here, but no problem. Let this get started. In the meanwhile, let me check. I think there is some question from someone just wondering any reason for -1, that one thread going to monitor. No, absolutely no monitoring or anything. That's what I'm saying. Why? Because finally, for parallelism, the best throughput will be there only and only when you have got the threads that you have got must be equal to the total number of cores on your machine. So I have 16 cores on my machine, so 16 elements must be processed at one point of time. So 15 threads will be picked up to process 15 elements exactly at the same point of time from the fork joint pool common pool, and one of the threads will be the thread from in which I have written the code, the containing thread. Which is the containing thread here now, friends? Tell me. I am writing this in public static void main. Which is the containing thread, friends? Tell me. Which is the containing thread? Come on. It's the main thread, isn't it? Yeah, correct. It's the main thread. So one of the elements will be processed in main. Rest of the elements, 15 elements will be processed in one of those, threads from the thread pool. So there are 16, elements getting processed at the same point of time. Because I have 16 cores, so one is the containing thread and the other threads from the thread pool. It ends up giving you, it ends up giving me the best throughput. That's exactly what was expected. You're getting my point? So why to not use the existing thread, also the one in which you are writing the code? That's how it works. But how the scheduler works is a bit different, but this is exactly how it works. Now we have got 16 elements out here. I will click right mouse button. Here I can take a timestamp, right, friends? I can very well take a timestamp. Okay. Kubernetes can have multiple pods for a given microservice of one core depending on the configuration of cores. What would that mean? The FGP has 0 threads? That's beautiful. I'm so sorry. I never tested that. I never tried that. That's beautiful question, Vasant. So very nice. I will have to check it out. I will have to see. So in that case, fork joint pool becomes meaningless, right? So even if suppose I never checked that, because you are right, yeah. you caught me. You caught me. Very fantastic. See, if you want to learn, and if you want to, well, I'm not calling myself as an expert, but yes, I've got reasonable amount of good knowledge with all of this multi-threading, parallelism, concurrency stuff and all, and I have gained that while training corporates like you all. That's the beauty. So if you've got to gain more knowledge, you've got to teach. If you've got to learn, you've got to teach. Now next time, definitely I'm going to take a look at when I spin my Kubernetes, or a Docker Swarm or any other such platform, and if I've got a Docker container, and if I've got I will just allocate one core to it, and I will see there I'll write some simple public static void main, and I'll check how many threads are there in fork joint pool common pool. I'll check that out, so that increases my knowledge. Thanks for asking that question, but I cannot really I do not have a concrete answer to it. I've never checked that out. Okay, thanks, Vasan. Thank you so much. Okay, so but let's assume even if it has got 0, but not that your well, There is no concept of parallel processing there in that case at all, right? Everything will execute in the containing thread itself. So if this is public static void main in such a Kubernetes, based Docker container, then in that case, and if it is configured to use only one single core, then in that case, it will all execute in the main thread itself. And of course, when you say one core, no parallelism. For parallelism, there must be two cores. Come on. Superb, right? There must be two cores, right? For parallelism as such, then there is no parallel. There is multitasking though. There is multitasking there. One thread gets sometimes sliced, the other thread gets sometimes sliced, the third thread gets sometimes sliced. But then if that is the case, friends, please do not make sure that you are not implementing these kind of things on in a pod and some kind of a microservice where you do not have multiple cores allocated to the container, the Docker container in which your application is working, or else there will be heavy context switching happening over there, and it will starve for the resource, right? So you've got to be careful. You must know where you are executing your application, right? In which environment, in which ecosystem you are running your application. That must be clear, right? So it's a good point. It's a very, very good point. Okay, so coming back here, friends. So you have your uppercase. I think there was another point by someone. So main thread is also the thread from the common pool with. No, it's not from the common pool. Hey, hello. I didn't mention that. I didn't say that the main thread is from the common pool. Absolutely not. The main thread is here. This is public static void main thread. It happens to be the main thread because I'm writing all this code in public static void main. Come on, man. Okay, if at all I had written this code in some REST handler in some kind of a REST handler of a REST controller, then in that case that thread would be one of the threads from the thread pool of the application server. Come on, yes or no? One of the threads, right, from the thread pool of the application server. That's what is going to execute. So that thread will be used in order to process, not that thread will go into the common pool or anything. Common pool is one singleton that always has the total number of threads equal to the total number of cores on your machine minus 1. That's how it is. Okay, so whichever is your containing thread, call it a containing thread, one of the elements will be executed in that containing thread. So please see this now. I click right mouse button, I say run as, and I say Java application. Please see. Okay, it executes. Can you see this? Everything actually almost gets completed in 1 second. You can see this Morgan Stanley processed in fork join pool common pool 4. So one of the threads from the common pool, and then IBM was processed here. But you see BNP Paribas, it picked that up in the main thread itself. See this. And then the other Nomura was picked up in 11, and this worker 2, worker 9, and then finally you get all the results out here, friends. Please see. You got this? It did not take 6 seconds at all. It took just simply 1 second. If you want, we can always take a timestamp again and we can see this. So if I have a timestamp here, it will definitely show 1 second. So how many threads? Is this elastic in nature? Hey, hello. Will it increase the number of threads, decrease the number of threads, or no? Absolutely not. It will always process my machine. I keep on saying 16. Why? Because I'm talking about my machine. It has got 16 cores. It is equal to the total number of cores on a machine. If suppose you've got a quad core machine, then in that case, tell me how many elements. If you've got 1 million elements, how many elements do you think will be processed in parallel? Come on, I need an answer. If it's a quad core machine, 4 cores. Come on, how many elements will it? Yes, 4. Exactly, Mithun. Absolutely. It's going to be 4. Yes, exactly 4, Balakrishnan. Thank you. Correct. That's how it is. If you've got a 32 core machine, 32. But can you change this behavior? Can you make it 16? If it's a 32 core machine, you say no, it's okay, 32 core machine, but I want to process the elements 16, or maybe 10, or maybe 5. I want only a thread pool of 5 threads. I want a thread pool of maybe 64 threads. Maybe your machine is just 32 core machine, but you say I want a thread pool with say 64 threads, and my streams must use that thread pool. Well, there is a way to do it. Use an executor service stuff and all. There is a way to it. I repeat, there is a way to do that, but by default this API does not provide you with that feature. Please see, Parallel does not have any such function. You can see this, which takes a parameter and I say how many threads to do, how many threads to use. No, and it does not have a feature wherein I say okay, use a so and so thread pool. Use so and so thread pool, use an elastic thread pool, use so and so. No, you cannot do that. I repeat, there is a way to do it. There is a workaround for that. We are not getting into that at all. I'm talking about the API, the features that the API provides. Stream does not provide out of the box that feature wherein I can just simply select which thread pool to use. It's fixed. I like it or not, if I want to do parallel processing, it will end up using fork join pool common pool only, whether I like it or not. I once again repeat, there is a way, there is a workaround to specify beyond the scope of our discussion as of now. Understand, I'm focusing only on the stream API because that's what I want to compare with what? Come on, that's what I want to compare with what? Flux. Here I do not have. As far as parallelism is concerned, we are not. There is yet another difference that stream does not provide back pressure. Flux provides back pressure. We will talk about that later. But then here, as far as parallelism is concerned, I do not have the power here. I have absolutely no choice. I cannot specify anything. It's going to use fork join pool common pool, and that's it. If at all parallelism is used here. As opposed to this, now my dear friends, you see, unlike this, you see, I create a new class, and this I'll say flux or I'll say parallel flux demo. Okay, and in this I'll go back to my streams demo. I'm going to pick up the same data structure here so that I don't end up writing it again. Okay, and I say main over here. Friends, please see this. I am going to use the same data structure. Okay, and what I'm going to do, I am saying flux of string. Earlier we had, in the previous example, we had stream of string. I'm saying flux of string, and I'll say uppercase clients is equal to, I'm going to do the same processing here also, but I'll say flux dot from iterable, and I will pass that clients as a parameter. You see, one would say, oh, okay, what's the difference? What's the difference? You see, streams demo here also you have got, like, you created a stream and then you started mapping stuff and all, and then here also you have got flux and you will start mapping stuff and all. Yes, I'm going to do the same thing, but then there are quite a few differences, many differences. Yeah, thank you. There are quite a few differences here. We are talking about the difference with respect to parallelism. We will see the other differences later between stream and flux, but then please see this here. And what is the first and foremost difference, my dear friends? Stream is blocking when it collects the data. Hello friends, stream is blocking when it collects the data. You see, when it is collecting the data out here, it is blocking. It is absolutely blocking. If you have 1 million elements, and even if you have got a 32 core machine, you may be able to process 32 elements in parallel. So 32 elements in parallel, and the next 32 elements, and next 32 elements, and so on, and you complete all the 1 million elements. But till the time all of those 1 million elements, after mapping is done or whatever processing you have done, till the time they are all not collected into this data structure, you don't proceed further here in this thread at all. You won't be able to reach here at all, because this collectors.to list is blocking. Correct? Whereas here flux, whatever you're going to write here is not going to be blocking, and you can very well subscribe also in a non-blocking way. Anyway, coming back, so I'm not getting to that. My focus is parallelism. So you've got from iterable. I'll just put my formatter off. Okay, I'll put my formatter off here so that I've got a habit of doing Control Shift F and it spoils everything. So you've got from iterable. I'm going to do the same thing, map, and I'm going to do exactly the same thing here. I'll have a lambda expression written over here for the functional interface java.util.function, which is expecting the value back. I'll say return x.to uppercase. That's what I'm doing here, friends. And then here I'll just simply put a semicolon here. That's good. But here I'm going to write, okay, thread.sleep, all right, for 1 second. That's okay, but even before that, okay, I'll do that. 1 second, okay, and I am going to print now the name of the thread, system.out.println. I'll say x, same thing, is processed in which thread? I'll say thread.current thread.get name. You can see this, friends, over here. It is processed in the same thread. I mean, in which thread I'm printing it. So you will see in which thread it's going to get processed. So what I'm going to do here is that I need a subscriber, of course. Till the time I do not have a like in case of streams, till the time you do not have a terminal operation, it's not going to actually swing in action. Similarly here also, till the time you do not have a subscriber, we did discuss about it, right, friends? We did discuss about it. See what subscriber actually looks like. So till the time you do not have a subscriber, a subscribe method is not invoked on publisher. Publisher will not even care to do the publishing of data. So coming back over here, I'll say uppercase clients, and I'll say dot subscribe, and I will use a consumer in the subscribe method, and I'll say I'm going to just print the values, right? You got this? I'm going to print the values here. You got this? Now see this, I'm putting a sleep out here, and I am also printing the thread in which this is going to execute. Let me click right mouse button, run as Java application, and you will see it actually does in the main thread itself. Can you see this here? You can see this. Nomura, Verizon, this is as a result of that subscriber that I've got, but Verizon is processed in main, IBM is processed in main, I've got BNP Paribas also in main, so it's all actually happening in main itself. I repeat, it's all happening in the main thread itself. I'm going to just put a comment out here so that you don't get that confusing SOPs. I click right mouse button once again, Java application. You see this, you've got Nomura processed in main, Verizon processed in main, IBM processed in main, BNP Paribas processed in main. You see this, right? Take a look at it, friends, yourself. It's all in the main thread, but I want parallelism. You remember in streams I did dot parallel and the job was done. Here also I'm going to just simply do what? Dot parallel, and the moment I do this, it gives me a compilation error. We will come to this in more detail later. It's simple. It's just that the moment you say parallel, it converts that parallel into a parallel it converts that flux into a parallel flux, but everything else remains the same. Now I'm going to execute. You see, nothing's going to happen. It's still going to execute in the main function. In the main thread itself. It's still in the main, though I have given parallel. Friends, please see, though I have given parallel, it is still processing the elements not in parallel. Actually, it's doing it in the same main thread. This is the big difference. I repeat, this is the big difference, friends. Please understand this point. This is the big difference. Here in case of streams, you do not have a choice to specify which thread pool to use. Here, not that you have a choice, not just that you have a choice, it's mandatory for you to specify which thread, which scheduler you will be using, which thread pool will you be using. And so to say, the better term would be not a thread pool. Of course, the scheduler works with the thread pool internally. It has got its own worker thread. It has got its own thread pool with worker threads, but here I'll have to say run on. I must specify a scheduler. I repeat, I must specify a scheduler out here. So in case of streams, you do not have a choice of specifying which thread pool to use. Here, not just that you have a choice, you have it's mandatory. It's mandatory. You must specify. So I will do what? I'll use a scheduler out here. You can see this. I will use a schedulers. And now you know very well, friends, what is a scheduler. You know very well. See, schedulers dot parallel. Now, friends, I'm pretty sure I don't have to really spend any energy in explaining what is schedulers.parallel. We have already seen that in action. We have seen that schedulers demo out here, friends. You can see the schedulers demo. We have already worked on this, right? We have worked on parallel thread, schedulers.parallel. We understood what does it. We have talked about the schedulers.elastic. We have talked about schedulers.bounded elastic. See the beauty here out here with Flux. You have the power in your hand. You decide whether it's going to be equal to the total number of cores on your machine. You see, schedulers.parallel will give you equal to the number of threads will be equal to the total number of cores on your machine. You say no, I want new parallel, and I'm going to specify the name of it. Instead of parallel 1, parallel 2, I'm specifying I will specify the name, say yabba dabba do, and I'm going to specify the parallelism. I said 32 threads. Cool. 32 elements will be picked up at the same point of time and it will be executed. Fine. Okay. And then you say, no, I also want to specify, or I don't want to give parallel threads will always be. It's mandatory. Yes, Vasan. You cannot get away with it. If it is mandatory, it should have thrown an error. No. It's okay. It's okay, Vasan. I and you will not decide how they must build their APIs, So they are more experts than us. They know what to do. It's just that it doesn't give you any compilation or any runtime error for a good reason. That's how the APIs are designed. They shouldn't give you that error at all, right? They don't. Let's not get into that line that their API design should have been this way. Let's not get into that, Vasan. Don't mind, please. So coming back over, that's how it is. Let's understand how it is, right? And how they have built it. So run on. I say schedulers. I've got a choice. I've got a choice here, friends. You see, I can very well say. Oops, I'm so sorry. That's bad. Okay, I can very well say bounded elastic. What is bounded elastic? It will create the total number of threads will be equal to the total number of cores on your machine multiplied by 10. That's what it is. And then if you say, no, I'm not. And so you know the difference between parallel and elastic. Parallel, fixed number of threads. Elastic, keep on increasing, decreasing, increasing, decreasing. If at all a particular thread is free for 60 seconds here, in case of bounded elastic, it's going to remove it from the pool. So there is elasticity over here. Not that you take the resources and you sit on it. You say, no, I'll keep on, because lesser the number of threads in the thread pool, the other thread pools will have some threads and they will get a chance to execute. I mean, you've got to decide how many threads you really want in a thread pool, right? I can also say new, bounded, elastic, and we have discussed that in detail, all of these thread caps and all, right? So I will just go back to my, I'll say new parallel. Okay, and here I'll give a name. I'll say yabadabadu or comma, and I'll say okay, I want 16 threads. Okay, whatever, I'll say, of course I do not have 16 elements here, but I'll say 16 threads, no problem at all. And now you see this, I click right mouse button, I say run as, and I say Java application. This time it's not going to execute in the main, it's going to execute in one of the threads from the thread pool. Friends, please see, you see this here, it's going to execute in one of the threads. Now the threads, you know that very well. If it's a new parallel, then the threads that you create, that it creates internally for scheduler, those threads are not the daemon threads, right? They are non-daemon threads. Suppose if instead of using this, I just say parallel. Now you know what, you know very well. See, I have already demonstrated that to you. If I say parallel, it will create threads equal to the total number of cores on my machine. But they are all daemon threads. So if I am writing this in my public static void main, which I will not in my real life. In my real life application, I will be using this in a Spring Boot application. There, I don't have my public static void main, right? The public static void main is a part of your application server, Catalina, whatever, right? But you don't write public static void main there. You write your code in REST handler. You write your code in a service. You write your code in some of the other DAO, IMPL class, maybe some kind of a class, a service class or some kind of a component, a Spring component. You will be writing this kind of code over there. You don't need to worry about that it's going to, end up and come out and stuff and all. You don't have to do that at all. It will all execute. But then one thing is for sure, the moment you say Schedulers.parallel, it will use one of the threads from the thread pool, and that thread pool happens to be what? How many threads will be there in that thread pool? Equal to the total number of cores on the machine, and they will be daemon threads. You don't need to worry about them at all. Let that be daemon thread. You will not have to do that circus that I'm doing over here. I will have to do a circus over here. I'll say thread.sleep. I'm putting my main thread to sleep so that I get a chance to demonstrate to you that you see this is executed in parallel thread. You see, so what I'm going to do here is I'll say 10 seconds. That should be sufficient. Okay, I'm just holding on to the main function. I'm holding on to the main thread so that I get a chance to get this executed. Why? Because the threads, otherwise there are daemon threads. You see this here. Here you go. Parallel 2, parallel 3, parallel 5, 6, 1, 4. You got that? It executes this in one of the threads from the thread pool coming from parallel. You could have said elastic. You could have said, bounded elastic. You have the power with you, friends. You have the power. And not that you have a choice here. You must and must specify. So as Vasant said, they should have given a compilation or some kind of a runtime error. No, it does not. That's how they built the APIs. But then here you have .run Schedulers.parallel is mandatory for you to specify. Otherwise, it does not really execute anything in parallel, at least in this piece of code. There are other ways also to, there is something called publish on, there is something called subscribe on. If time permits, we will definitely get onto that also, right? That's exactly how it is. This completes our discussion on this completes our discussion on how or rather parallelism with respect